Welcome to XL Catlin Arctic Live. We're here at the UK Arctic Research Station in Ny-Ålesund on the island of Svalbard. Now that's halfway between the top of Norway and the North Pole. And we're here on Arctic Live conducting both scientific research and education outreach. The science team are currently out on the fjord just behind us here, and they've been looking at microplastics in these Arctic waters. How many are there? Are there any in fact? And where might they be found in the water? And we've been here in the Arctic Live studio at the UK Arctic Research Station sharing ideas and sharing experiences with Nick Cox this morning, learning more about the science, and back again for our second Arctic Live investigation today, and we'll be looking here at keeping warm in the Arctic. And just to leap straight into that, let's see who we've got. We've got Mr. Nolan's class in Rill. We have Northley Middle School in Aston, Pennsylvania, and great to have you with us, and great to have you on this keeping warm investigation. And really, keeping warm is so important in the Arctic. Some of the questions we've had already today have been about what are the toughest things you face in this environment, and keeping warm is definitely one of them. Today is actually a really nice toasty warm day. I think the temperature is an amazing 1 degree, or about 34 degrees Fahrenheit. So we really don't need all our cover, but certainly on past trips where the temperature has been in the region of -40 Fahrenheit, -40 Celsius, and then even down to -60, 70 Fahrenheit with wind chill, it certainly needed some of this clothing. And really, there's lots of different things you might be wearing in the Arctic. If you're operating equipment, thin gloves might be the order of the day. But if you're travelling across the tundra on a skidoo when your hands are very exposed and got a lot of wind, then you'll need something like a nice big warm skidoo mitt like this. Really lovely and toasty, covering the arm around here. And this this very nice furry leopard skin effect here, not a fashion statement, but rather to put against your cheek and blow, and you can get that really nice pocket of warm air, and you can get rid of frost nip or really chilled face. So that's really nice to have. So a great bit of kit travelling by skidoo, and of course wonderfully a nice warm hat. So often would be wearing a nice warm hat, but today I'm not needing one. And very, wonderful to be operating from the UK Arctic Research Station, where we're nice and warm inside as well. So what we're looking at is the insulating properties of various materials, and the way that we're going to test that is by choosing 3 materials from around the storeroom at the UK Arctic Research Station. You choose yours if you're following along back in the classroom. And then we're going to take these containers, put some hot water in them, make sure it's not too hot, so around 40-45 degrees Celsius, and then wrap them up using different materials and put them outside for a while to see how well those different materials insulate the water. So that's replicating how well these different materials will keep us warm when we're in the Arctic environment. So Ellie, hi Ellie. Ellie's been behind the camera up until now. Ellie, if you can come and join us down here and help.
Yes, of course.
Fill these things.
Hi everybody.
Grab your mic there. Sorry, I've seen them knocked over the various bits and pieces that we're using. So these are the items, Ellie, that we've chosen. I don't know what you think. Let's also see what our students might think about what's going to give us warmth. We've got a slightly ragged, broken glove.
Yeah, I'd be interested with this one because it's so thick and warm and quite heavy actually, but it's not in the best condition. So given the choice of something that's really thick and bulky but perhaps has some weakness to it, I'm not sure whether that's going to be warm or not, but it certainly feels nice and cosy.
Okay, so what else have we got? I think they're falling down beside you.
We've also then got something that's quite common here, which is a microfiber fleece. It's a very thin fleece, so it feels quite flimsy.
Okay.
But that may or may not have some thermal heating properties.
Great.
That's quite common for us to wear as a base layer.
You've got one on
so
your
I
neck
have
there.
what's called a buff, which you can wear on your neck, or if it gets really cold, you can use your breath to heat your own face.
Be careful those don't stick to your face. I've had people have that stick to their beard.
Froze to the beard.
Yeah.
I don't have that problem with my beard, so
No, you're working on your beard, are you?
working on it.
Okay.
But you can use those. So we'll try that fleece as well. Normally that's an underlayer.
Okay.
We'll see how well that works. And
else
then
we got?
finally the third item. This is not clothing, but this is something that's known for insulation, for keeping things warm. And that's bubble wrap, which I can't resist but give it a bit of a pop.
Okay, so I've got some hot water here. Again, be careful not to use water straight from the kettle, straight from the hot tap. But the hat, oh, crikey.
We're looking at, for example, with clothing, keeping our body temperature warm. So our body temperature is about 98 Fahrenheit, 37 Celsius. So we don't need to use boiling water. Just nice and warm, nice and toasty. And you can do this very carefully with your teacher helping you as well.
That's about the same, except for the middle one. I need to put some more on that.
Yeah.
There we go.
Nice.
Great. I'll just find out what the temperature is in here. Where are we? Go on off button.
So boiled this a few minutes ago, so it should have started to cool down a little bit.
About 82 degrees Celsius.
82. Okay.
So let's put the tops on there. It's far too hot really for use in the classroom, so we ought to be pretty careful. Maybe half that. And then which one should we start with first in terms of doing our wrapping?
Let's do the bubble wrap because it takes a while.
Okay, do the bubble wrap there.
You do the bubble wrap and I'll do the...
Put a couple of
bands.
plastic bands, keep that in
And
place.
so you can work out in your groups with your teachers what's the best way of sealing this. You might have a better way. You might have your bubble wrap cut to a different size, for example. So you've got to try and think about how to wrap it tightly and fairly.
Yeah, just on that fair idea of fairness, we've noticed that we've used the same containers for each of these materials, and we've tried to put the same amount of water in and at the same temperature to make sure as many things are the same as possible.
Yeah, so the temperature, it doesn't matter what you start with, whether it's 40 or 50 or 60 degrees. The main thing is that all three come from the same pot of water, so they all start at the same temperature. Right, so then this micro fleece, double this up. How you want to do it. Like so.
Great.
And elastic band again.
Why not? Why not? Get a couple of those over there. You've got that on there.
Again, you can have a go at your own experimental design here, depending on which materials you're using, whether you want to tape them or use elastic bands, or how you're folding and wrapping, and try and be as consistent as possible.
Well, I think this
one's fair. It's only one way of putting a glove on a pot of water.
There we go. Fantastic.
Brilliant.
Now I think we're going to head outside. If you don't have the Arctic through a door of your classroom, then you can always put these in a fridge for 15 to 20 minutes. So I'm just going to clip on. Those both on there. And we'll go and put these outside carefully, taking them one by one. And we'll just put them outside here. Get the microphone tangled up. And let's go and grab those other two. Thanks, Ellie. Okay, that's one more. And the final one is the gloves. Okay, I'm just going to pick up a couple of things while I'm out here. And we can take these back and talk about them inside. Right, there we go. Let me shut the door, keep us a bit warmer in here. Great. So just really wondering how we're doing. If we have, I think we have live now, so just see if we've got any ideas about what we think might be working. So Northley Middle School thinks the fleece is going to be the best insulator. Hello Portugal. Oh, we've got Portugal here as well, that's fantastic. And Mrs. Quickle's class thinks the big glove will be better. So we've got about 15-20 minutes to go, just to let those cool down outside. But whilst we're doing that, I'm going to look at a very different type of glove. Now, as you may have noticed, that we get lots of animals up here that don't really wear big fleecy jackets or even bubble wrap or any of that kind of thing up here in the Arctic. Instead, they have adapted to these environments in different ways. And what I'm going to do is just give a little bit of a test to see how one adaptation might work. So this is a blubber glove, and I'd love to get some ideas about the types of animals that have blubber on them. I'm going to see if blubber is effective at insulating against the cold. So what would be great if you can send through some names of some animals that have blubber to stay warm. I will try and keep my hand in the snow for as long as possible for it not to hurt. So what I really want you to do is send through those names quickly so I don't have to keep my hand in the snow for too long. If we can get 5 or 6, then I think that's going to be okay. Ellie, do you mind timing how many seconds I'm going to keep my hand in this snow for? This is pretty unpleasant.
Okay.
Ow, sorry, they're not there yet.
Right.
Pretty unpleasant part of the job. And so this is a pretty stupid thing to do. Snow is incredibly cold. Ordinarily, I don't know what the temperature of this is. Let's see if I can just put this temperature thing in here. It's saying it's sort of about ½ a degree. Often it can be really, really windy. You can be operating camera equipment, and you can just need to operate something quite fiddly, and this is really painful. Don't. If it becomes painful and you're doing this at school, then just take your hand out because
this is 1 minute.
This is 1 minute. This is ow. I need one of those big gloves, really. Just need a sort of second, or they're all managed to get 2 gloves in the same direction. Like, let's see what's from it. Put that in there for now. Sorry. if you ever see someone windmilling their arms on a polar expedition, they're normally the camera person who has lost all sensation in their fingers and just needs to get forced blood back in there. There we go. And then the deep joy is, after many, many years of not really having any sensation in the end of your fingers anymore. But there we go. The joys of working in the polar regions. Now, the theory is, have we got any... Oh, here we go. Thank you very much. We've got Warwick Academy in Bermuda as well. Mrs. Quickle's class says the following animals have blubber: polar bears, penguins, Arctic foxes, orcas, seals, blue whales, walrus and narwhals. Absolutely amazing. Not huge amounts of penguins up here, of course, them being an Antarctic animal. Otherwise, all fantastic. So, this is my blubber glove. So, I should be able to keep my hand... How long did I keep my hand in there?
A minute.
A minute.
You've got to beat a minute.
I've got to beat a minute with my blubber glove into the snow. I need probably some encouragement, or probably something going on. But this is one of the ways that animals in the polar regions keep their themselves warm. In fact, if you got right down to it, a polar bear this feels like an enormously silly thing to be doing. A polar bear's skin is actually black underneath all that white fur. So there are a number of different, and black of course absorbing more heat. There are a number of different adaptations from the fur, so it keeps a nice warm layer of air next to the skin, to having dark skin to absorb heat, to having a thick layer of blubber as an insulating factor. I think this isn't too bad actually. I'm not saying that you should walk to the North Pole smeared with butter or margarine or something like that, but this is definitely something to try in the classroom. Again, if it does feel painful, please don't keep your hand in there. But I reckon we can... How long have we been going for?
That's a minute.
That is a minute. This is pretty good. I can see why the sort of the narwhal it hurts a lot afterwards when the blood goes back into the hand. Yes, when you... I'm just seeing these things on here. Yes, there is various amounts of pain involved in this process. And we have the Year 3 students of Bermuda are actually thinking the fleece outside is going to be the best one. We'll go back out and have a look at that. I'm just going to take my hand out because actually blubber
Minute 40
gets top marks. So the blubber glove there, you can see, still encased in the snow. In fact, I managed to melt some of the butter in there. It's getting quite hard being left outside. So I'm suitably impressed by the butter. I'm just going to take that off now and put it down here. Oh, I think we're gonna get through some of your questions because they're really great. And then in let's go for 10 minutes time, we can go out and we can get there's a sort of experimental batches out there. So where are we? I'm going with Mr. Nolan's class in real. We have Isabel, Efi, Jessie, Gemma, Grace, and Emmy. Question 1 from Olivia and Furley. What is the highest and lowest temperature ever recorded in the Arctic? Well, I don't know if ever recorded, but for me, the highest temperature I've been in the Arctic is about 3 or 4 degrees Celsius. For those watching from the States, that's sort of mid 30s to 40 degrees Fahrenheit. And the coldest temperature I've experienced is 48 degrees. And that, just working that out, that's about 55 below in Fahrenheit. And that's about, for Svalbard at the moment, that's probably... It's more like 35 below, so 30 degrees Fahrenheit negative. to about 10, 15 degrees, so that's 50, 60 Fahrenheit. So that's the kind of temperature range that you get. So it's quite huge. I mean, just thinking that's a sort of 50, 60 degree Celsius range, which is lots in Fahrenheit. My maths has escaped me. But for 50, 60, then that's going to be about 90, 100 degree range in Fahrenheit. Where are we? Next question from Gracie and Svana. What kind of food do you eat and how is it supplied? We eat very, very well here. So it's an international science settlement. The food mostly comes in by ship, with a little bit of fresh food coming in by plane. And all the different stations eat at a central canteen. So we have 3 meals a day, and it's great. Breakfast selection of cereals and toast and all that kind of thing. Lunch was great because it was recycled food from the past couple of nights, so everything is sort of minimised on the waste front, with different sort of foods coming, being reused and made into different dishes in different evenings. And then dinner, I'm not quite sure what we're going to have tonight. I suppose the main difference is you might have reindeer on the menu every now and again, but that's probably the main difference. And the amount of biscuits you end up eating. I think he's shoveling a lot of biscuits. The cold is the excuse, and that cold's not quite here at the moment, so I'm not quite sure what the excuse is. But there we go. Ruben and Charlie, how far do you travel each day and how is it achieved across the ice? That's a great question. At the moment we are researching on the ocean, so we're travelling by boat, and we might be out by boat, on the boat for 6, 7, 8 hours on a day. If you're doing glacier research, you will probably be travelling by skidoo or snowmobile, and again out for an 8, 9 sort of odd hour day, travelling sort of up to the field site and back. Harry and Caleb, why did you decide to work in the Arctic, and how do you survive the extreme cold? So the reasons for working in the Arctic there's a science reason, and there's also an education reason for working in the Arctic. The science reason is that we are looking at ocean acidification. That's where carbon dioxide in the atmosphere is absorbed into the ocean and changes its chemistry, and that change can affect, that pH change can affect the animals that live here. And that process is happening fastest in the Arctic. So the Arctic can act like an early warning system, a sentinel system for other oceans around the world. And the other piece of research is looking at microplastics, and one could assume that the Arctic is a pristine environment, so we're searching to see if there are any microplastics here, but also it could be seen as a sink or a gathering point for microplastics, because once you get to the Arctic, there's sort of nowhere further north to go. So does it collect in the Arctic, and could it be dropping out and affecting the environment here? And on the education side, it's a bit far for a school trip, but it's an incredibly important part of the world. So these broadcasts are helping to bring it a little bit closer to classrooms like yours. What is the research centre made from, and what research are you currently working on? Great question. The research centre is made from wood, and it's built on the permafrost, so there's big sort of stakes going down to the ground. And one of the problems we have here is the danger of fire. So very, very dry, very, very wooden buildings can go in as little as 5 minutes if a fire starts. So that's what we're living out of up here at the moment. Just going to take a glance over at the live stream to see what questions are coming through there. So we have Year 7 at Bermuda High School would like to know how long have you lived in the Arctic? Great question. So I haven't lived in the Arctic. I have visited a few times. This is my 6th trip to the Arctic and my 7th polar trip overall. And here for just 2 weeks this year. So 2 weeks of science and education outreach. But there are people who work at Neolesund who spend years here, and they work here full time and just go home for the holidays. Brittany Over, Mrs. Quickle's class, we would like to know if you've ever had frostbite before. Very luckily, I haven't had frostbite. I have had frostnip, and my left hand is still feeling slightly odd after keeping it in the snow for a minute. Frostnip is when your skin sort of freezes, feels a bit sort of candle waxy, sort of frozen chickeny, and you can melt that and you can get the blood going again and melt that, and it's all nice. And those good old gloves that I was showing you earlier, good for combating frostnip as well. And here we have from Year 3 students in Bermuda at Warwick Academy. What animals do you see in the Arctic? At the moment, this time of year, there are some reindeer lurking around on the foreshore somewhere. So there's just down here, there's an Arctic fox that lives up by the kitchen. There might be a polar bear around, who knows, and plenty of bird life. So eider duck, little auks, fulmars and gulls. So more and more bird life coming back to the fjord. And if we're in luck, we might see a beluga whale at some point this trip. So we'll keep our eyes out for that. And also a few seals around. And there's a walrus colony just down the fjord as well. So back to, I think we've got a couple of minutes before we head outside and to find our pots and see how they've been getting on. I'm just going to go through some of the great questions coming through in advance from Northley Middle School in Pennsylvania. We have, how do you study the Arctic? Are the tools you use different from the ones you would use in a warmer climate? From Snyder George. Great question. So some of the things that you do are very, very similar. So for instance, if you're finding or trying to find microplastics in other rivers or oceans, you would also be trawling for them using the kind of system we're using at the moment. I suppose the big difference is the cold, and so you're wrapping up much warmer. You might be studying how different environments change, but you might be travelling differently. So we could use a skidoo or snowmobile to get to a site, then a shovel to take snow samples, or an ice corer to take snow samples, and you might use a different system in warm climates. But the basic science, looking at environmental change, is still the same. I want to know what the scientists' daily lives are, what are their work hours, what do they do when they go to work, what is the coolest thing they have ever seen. Wow, these are lots and lots of questions. When you first got to the Arctic, was it hard to adjust to 20 hours of light and darkness? And this is from Julia and Tori. I'll try and take this one at a time, Julia and Tori. Some great questions there. The work hours, wow. Well, I think we get up at about 7:30. And working and packing and organising, getting out at 9 o'clock onto the water, and then probably back at base 4:30, 5. That's a full day, but you've got about 2 or 3 hours of organising and packing at the end of it, which is beginning and end. So it's a big old long day. On the outreach side, I think we have it a bit harder, don't we, Ellie? It's a sort of like it's a 7 o'clock start and a sort of midnight or 1 o'clock finish at the moment. So there's a lot of organising on that side. So be a relaxed scientist. Although they do work very hard, and the sorting of samples can take a very long time. And I've seen science teams, especially at this time of the year with the 24-hour daylight, up in the wee small hours, making sure all the samples are properly processed before they're analysed back at the lab at the universities across Europe. Coolest thing they have ever seen, you're going to have to ask them. So we have great interviews with Katie Smith tomorrow and Nick Scott on Wednesday, so tune in for those, or submit questions you'd like to give them in advance. And they are two members of the science team, so very much get their first impressions. And when you first got to the Arctic, was it hard to adjust? I think we came up with, that's a really good question, we came up with this sort of phrase, lat lag, rather than jet lag. So lat lag referring to sort of changing your latitude, going further up towards the North Pole. And so starting off in London, where the sort of days, nights feel like a sort of normal summery spring balance, up here to 24-hour sunlight just takes a bit of getting used to. So definitely a bit of lat lag coming up here. I think it's just about time to go out and have a look at how our samples have got on and to see which is the best insulating material, whether it was the big glove, whether it was a bubble wrap, or whether it is the fleecy, the buff, the sort of neck fleece. So do be thinking about that. Do discuss that in your class now as we go outside and get those samples back. And don't worry, we will come back to the rest of the questions that have been sent in before the end of this session. So let's go outside, get those samples, and then see which is the best insulator. Here we go. Come outside and grab them. Oh dear, we've had a bit of a knockover. The wind got up and knocked over the glove. You can see if that made a difference. So put down those there, and then we'll just pop outside and get the goofy one. Check over the mic. There we go. Get warm and cosy inside again. Come and sit down. So what are people wondering? We've got some blizzardy questions coming up. So I'm really interested in the glove. I'm going to start with the glove. It did fall over, so I'm expecting this to be the coldest, because I think this fell over and there's got lots of wind up onto there. So I'm expecting this to be the coldest out of all of them. So just sort of open this up. Oof. So we started at 82 degrees centigrade, and we are now down to 40, 39, 39, 39. So just make a note of that, 39 degrees for the big glove. Okay, well, definitely not wearing a fallen over big glove on my little trip to the North Pole. That doesn't seem to be working, although it was very toasty when used properly. Next up, let's have a look at the fleece. I think give this one a go. Take those rubber bands off. Open this up carefully. Oh, this feels nice and toasty. Get that open. There we go. So we had 39 for the big glove. We have a whopping 47.5 for the fleece. So I am wondering what people are thinking. Is the fleece or the bubble wrap going to take first place? So currently we've got Big Glove at 39. We have Fleece at 47.5. And we have the bubble wrap. Let's put the elastic bands here. Feels quite warm. Could be good. Here we go. 40, 42. So we have bubble wrap at 42, Fleece, the winner, at 47.5, and the fallen over, slightly ripped, Big Glove at the bottom with 39. Well, I think that just goes to show, don't walk across the Arctic wearing bubble wrap. Definitely don't have holes in your glove and sort of fall over and let the wind get everywhere. Tuck everything in. And the fleece there is a great material to wear. I'm lucky that's what I'm wearing today as well. Just coming on to our test, it is a pity that the glove blew over, but thinking about some other ways of making our test fair, think about things you could have done. So we wanted to test which material is most effective. So we want to use the same containers, same amount of water, same temperature of water. We could even think about the same amount of material, whether that's weight or volume, depending on what you want to test, and also the same way of attaching it. And we didn't put rubber bands around the glove, for instance. Think about those different ways in which you can make this a fair test. I'm just wondering whether you've done this test in the classroom whilst we've been doing it, what materials you've chosen and what you think might have worked. Whilst you're doing that and reporting back via our live chat, let me just get back to the questions from Northley Middle School. So I know there are a few more. I've got Megan's questions to talk to, and Rachel and Samuel as well in the 7th grade. There's amazing questions coming through. So we have from Megan, how much plastic do you encounter in the water on a daily basis, and do you know any safe methods to retrieve plastic from the ocean? Really, really good question, Megan. The particles we're going to find up here in the Arctic Ocean are probably going to be invisible to the naked eye. That's certainly what we are thinking so far, and that's what's been found by other expeditions. And so we won't know truly the amount of plastic that we found in the Arctic until we get back and view these samples under a microscope. Although I say that now, but the team are due back in an hour or so, and so we'll be able to ask them, did you find bigger pieces of plastic when you were trawling today out on the outer fjord? Which that's what they've been doing today. They've been trawling out on the outer fjord, and we can ask them and we can put that up if they found anything bigger. And Megan, the second part of your question is, do you know any safe methods to retrieve plastic from the ocean? And what we're doing at the moment, the science method that we're using is trawling. So we have a net with a very fine mesh, and it might be, you know, if you think about getting shrimps from a rock pool, same kind of idea, but dragging that net through different layers of ocean water and seeing how many plastics there are in each of those toes. They're called, you know, when you tow it for 10 minutes. Sorry, each of those toes. So that's what we'll be doing, and that's the way that we get plastic out of the ocean. There's lots of questions all typed together here from Rachel and Samuel. Oh, and great to hear! Big cheer from Bermuda. You got the prediction right. So congratulations to all of you who predicted fleece. But I'm going to crack on with these ones. We've got where are we? How do plastics in water affect humans? That's a great question. So they can get into the food chain, the human food chain, and it's an emerging area of research to find out what impact then that has on human health. So really, really interesting question, but certainly those bits of plastic can come into the human food chain through mussels that we might eat. And the other thing to think about is that also plastics is so pervasive. I think I saw one study that said that even if you were eating plastics through mussels, for instance, through a filter feeder, you will probably be breathing in more plastic from your domestic environment in terms of small fibers than you were eating from the mussel. And I know that it affects animals, but how does it affect humans? That's also another question. If you can just sort of look on, this is all sort of plastic pollution and human health. Just going over what we know so far about how plastics can affect marine life. You've certainly probably seen on television or in the media larger animals being affected by sort of large items of plastic. So we have pictures of seals and turtles with plastic wrapped around them, and also sort of whales getting entangled, which is sort of horrific sort of imagery coming through there. We've got sort of pictures of albatross chicks with their stomachs full of plastic. So we've got that physical damage that is happening to a large array of marine life. But also to remember that plastics can get smaller and smaller and smaller, what we call microplastics, so that it becomes at a size where it can be easily confused by plankton, by the sort of small shrimp-like creatures, for instance, in the Arctic, the copepods, eating normally algae, but confuse that and eat some microplastic. So again, on all these different scales, we've both got accidental entanglement, animals confusing plastics for their food stuff. So whether that's a turtle with a plastic bag and a jellyfish, or it's a copepod in the Arctic confusing a tiny piece of microplastic for algae that it might be eating. So that physical damage blocking up the gut is definitely an adverse impact on the marine life. Further impacts are current areas of study. So what else do we have here? Are plastics ever going to outnumber the amount of fish in the Arctic Ocean? I think this is definitely also an emerging area of research. We need to know how much plastic there is in the Arctic Ocean, where it is, and then we can start to answer some of these very, very important questions. But certainly, based on what we're finding at the moment, the past couple of papers coming out, that there is a lot of plastic in the Arctic Ocean. And will the oceans ever become so polluted that we can't even swim in them anymore? And this is Rachel and Samuel again. And in terms of ocean pollution, there are so many different pollutants, and I'm not quite sure which ones you're referring to here. But it's really our choice, and your choice as well, about whether we see the oceans as a sink, somewhere where we can just throw all our dirty things. And we used to think that the ocean was so great and so vast that we could just chuck anything in there, and the dilution, would be the solution. And that's looking like it's not true. So the chemicals and the waste and the pollutants that we're putting into the ocean, like plastics, are becoming more and more pervasive and causing more and more harm. And it's really up to us as human society on land about how we manage our resources and we manage our waste and our relationship with the ocean. So will it ever become so polluted that we can't swim in them anymore? There's been great work done on improving beach conditions, swimming conditions on the coasts of the UK. More work can be done, but it's really up to all of us to make that happen. We've got just a couple more minutes, so I'm going to switch to the live chat to see what we've got coming through there, and then I think it's going to be a goodbye in just a couple of minutes. So we have, we would like to know if you have ever been stuck in a blizzard. Never been stuck in a blizzard. Luckily, managed to get back to where I was staying, whether that was a tent or a base. So luckily, haven't been stuck out in a blizzard. But you hear of people who go off for 4 months to study a glacier and maybe get only maybe 1 or 2 days in those 4 months because they get stuck in a storm and have to stay for the rest of the time in their tents. So that must be quite frightening. And last question for today, have there been any snowstorms when you've been studying there? There's certainly been snowstorms in the past. Last year we had winds of, I don't know how strong they were, but gale force winds, strong gale force winds, and wind chill down to -65 Fahrenheit, -53 Celsius. That was certainly pretty punchy. So although it looks wonderful and calm, and the team have been out happily sampling on the boat today, the weather can change very quickly and very dramatically. Thank you so much to all the classes. I'm just going to check through. We've had Mr. Nolan's class in Rill. We've had Northley Middle School in Pennsylvania. We've had the Bermuda High School. We've also had Warwick Academy, and great as well to have a class from sunny Portugal join in. If I've missed anyone, please let me know. We'll give you a shout out in the next 30 seconds. But before that, thank you very much for joining in. Thank you for your great questions. Don't forget that we have 2 more sessions today. We've got an interview with the UK Arctic Station manager, Nick Cox, in about an hour's time. And then we have an open Q&A, asking anything session 2 hours after that to wrap up today. We've got a packed schedule also for Tuesday, Wednesday, Thursday. We've got interviews with scientists Katie Smith, Nick Scott, and the wonderful science communicator behind the camera at the moment, Ellie McKay. Plenty of live investigations and Ask Me Anythings as well. Do tune in to the Digital Explorer YouTube channel. We'd love to see you here and love to take your questions from the Arctic. But for now, we've had Mr. Brennan's class in New Jersey. Thank you so much for being involved. Big thank you, and big thank you to Mr. Brennan for coming in at the last minute. Been a great fan of Arctic Live over the years, and I've done a little bit of a workshop. In fact, managed to get down to, I think, Lawrence Intermediate School in New Jersey, if I remember the name of your school. So thank you for being part of Arctic Live again. And it's goodbye for now from the Arctic. See you later. Thank you.